Okay, so those are the three main challenges you want to think about. You want to think about cost, you want to think about performance, and you want to think about data management. So in the context of those challenges, now I want to talk about the solution space, and I'll spend the most of the remainder of the talk talking about how we think about these problems and solving these problems. So in the solution space, there's kind of three things we want to think about when we think about how to solve these problems. One is, how many clusters are we going to have? You might do one giant cluster, you might not. Another one is, how many data sources are we going to have? And in Druid, this is what we call tables. So, and then finally, how do we ensure quality of service? How do we ensure that performance is not just sometimes great, but is actually consistently great? So let's first talk about number of clusters. Well, one option is one giant cluster. And if you have one giant cluster, you are going to have a pretty simple deployment. You have one system. You kind of put all your eggs. This is the philosophy where you put all your eggs in one basket, and then you just really pay a lot of attention to that one basket, which is relatively simple. It is you're going to get a lot of good resource sharing with this, with one big cluster, meaning which is actually really. I want to dwell on this for a bit because it's really key with this kind of system. One of the things that tends to be true about workloads that people put on data applications, the kind of which that are going to be powered by Druid, these data applications tend to have somewhat spiky usage. And what I mean by that is the usage graph doesn't just look like a flat line, a consistent number of queries per second. Now, you might get 50 queries per second on average, but what that means is that sometimes you're getting a much lower number, like 5 or 6, and other times you're getting a much higher number, like 100 or 200. It tends to be somewhat spiky. And one benefit of having one big cluster in a multi-tenant situation is that these spikes are actually going to be, they're not likely to be correlated between customers, between tenants. And so you could, you get this resource sharing ability where they're not all spiking at the same time. And so you have a bigger pool of resources that's able to absorb spikes at different times from different tenants. Of course, if they do all spike at the same time, you'll be in a little bit of a pickle, but that is it's not a common thing, and yeah, it's not that common. So this is the most cost efficient. This is the most cost efficient way of doing things. This is the most cost efficient because really of the resource sharing. Okay, let's talk a bit about other options. One cluster per tenant. So one cluster per tenant is a much more complex deployment model, I would say, because you're going to have you're spinning up and terminating clusters all the time. You get no resource sharing. Everything's dedicated to a single tenant, much higher hardware cost. Most people that do a multi-tenant application choose to do one big cluster rather than one per tenant. And the reason really is, it really is down to those benefits you get by doing one giant cluster. The benefits of getting resource sharing, lower cost, and the ability to put all your eggs in one basket, so as it were, and really pay attention to that basket. So that tends to be the way that people go. All right, so if you are going to do one giant cluster, the next thing to think about is the number of data sources. And the simplest thing to do, or a simple thing to do, is to have one data source. So one giant cluster, one data source. And this is a simple model. It's highly scalable. And the reason I say it's highly scalable is because Druid is designed to be able to handle a very large amount of data into single data sources. That's it. Individual data source in Druid is scalable to a very, very large degree. So this is an extremely scalable model for that reason. Data management, however, is fairly inflexible. You get a lot of power, you can do a lot of stuff, but in order to do things like updates and deletes and backfills, you actually have to reprocess whole partitions of this table. So these tables are always going to be partitioned first based on time, and then based on something else, potentially. And if you're doing updates or deletes or backfills, you'll always be doing them on time partitions. which means that if you need to delete data for one tenant, then you'll actually, and you delete data for one tenant from, let's say, prior April of this year, you'll actually be reprocessing all the data for every tenant for April in order to do that. So you get plenty of power, but inflexible in terms of how targeted it can be. And so these data management operations can be fairly heavyweight. It's also difficult to make special exceptions. And what I mean by that is sometimes you have certain tenants that you have a special relationship with because they might be your biggest customers or your most important users. And you may want the ability to give them extra retention beyond what other customers get, or even maybe less retention just because of the amount of data there is. One way or the other, you may want to make special exceptions for certain special tenants, and it's harder to do that if they're all in one giant table. So one table, very simple, very scalable, but you lose some flexibility in terms of giving people special treatment and in terms of doing historical data management operations. Let's look at the other extreme. One data source per tenant. It's also simple in a different way. One is simple. One data source period is simple just because there's just one giant table. One per tenant is also simple because the mapping is simple. There's many of them, but there's one per tenant, and so it's a straightforward mapping. Data management is flexible and also relatively simple. If you're deleting data for a tenant, then you don't have to worry with the data for any other tenant. You're only touching that one tenant's table. Same with updates, same with backfills. The big downside is that it's less scalable. And I'll talk a bit about why that is in some later slides, but for now, I just want to, for now, suffice to say that there is a soft limit of maybe a few thousand data sources above which certain things will not work as well as you'd like them to work. And so you don't want to have a Druid cluster with 10 or 20,000 data sources in it. So this is something that's scalable to on the order of thousands of tenants, but if you have tens of thousands or 20 or hundreds of thousands of tenants, you're not going to want to do this. It is a good solution, though, for situations where there's a small number of very big tenants. And then finally, there's a hybrid model. So take the two extremes, meet in the middle. And what this means is you have now a complex mapping of tenants to data sources. Maybe one data source has these 10 tenants, this data source has this one tenant, this one has 100 tenants. Data management here is also pretty flexible. It's also relatively targeted, but it's much more complex. It's complex because instead of having one giant table, instead of having one per tenant, you now have this mapping you have to think about. This mapping you think about which tenant goes to which table. That's not necessarily a simple mapping. It is highly scalable because you are grouping these tenants together. And so the number of data sources, number of tables you're going to have is manageable. And it's really a good idea when you have some heavy hitting tenants. This is when it's most commonly used. So a situation where you have a large number of them, let's say 100,000 tenants, but a small number of them, maybe 10 or 15 are really heavy hitting. And so you might give a dedicated data sources to those 10 or 15, and then put the other 10,000 in a single data source. That's the most typical way that the hybrid model is used. Okay, so that's number of data sources. That's there's one giant data source is an option. One data source per tenant is an option, and then a hybrid model where you combine both and you get some of the flexibility of one per tenant and some of the scalability of giant data sources.